All right, this video is a response to a question that was asked through email. They're asking just ideas of how to work out a geometric sequence given certain clues. They asked for number 8 on page 393 as a similar kind of question, so I'll answer that. And then maybe I'll go on to answer another question that I proposed on the description section of my YouTube video for geometric sequence chapter 6.5. Hopefully those two example questions will help you with your problem sets and whatnot in the future. Without further ado, let's get to it. The question 8 says, which term in this geometric sequence is going to be 192? Starts off with the first term being 3 over 64, and then they give you two more so that you can confirm what the actual ratio is. So let's do that. Okay, the second term divided by the first term, which is essentially negative 3 over 16 times 64 over 3. That's a 4. And that's a negative 1. That's going to be negative 4. Let's test that and confirm it once again. The third term divided by the second term, which is the same as 3 over 4, times negative 16 over 3. 2 to the 4, that's a negative 4. Okay, so essentially I can confirm through the math that I just did above that the term number for this geometric sequence is going to be a, r, n minus 1, which is a, r, n minus 1. The goal of this question is to figure out which term number is 196. In other words, which term, what's the n value? That's what we're looking for. So taking this, I'm going to take 192. I don't know what the n value is, but I do know I started with 3 over 64. And I do know I've multiplied negative 4 a certain amount of times. I'm going to do out some algebra, multiply both sides by 64, which gives me 192 times 64. That brings me 12,288 equals 3, negative 4, n minus 1. Divide both sides by 3. 4,096 is equal to negative 4 to the power of n minus 1. From here, we can use logarithms, but assuming that you do not know logarithms, I am simply going to guess and check. Negative 4 to the power of, so 4,096 is equivalent to negative 4 to the power of 6. Negative 4 to the power of 6. Okay, and that is equal to the right side, negative 4 to the power of n minus 1. That means 6 is equal to n minus 1. N must be 7. Therefore, the seventh term in this geometric sequence is 192. Done question. To continue on, I'm going to quickly tab over to the question I asked on the description of my Google Classroom, and it goes something like this. And I think a question like this is a little bit harder, but it will definitely help you out. And it goes like this. I have the fifth term being 81, and the ninth term being 6,561 in a geometric sequence. So I give you that. What's the 11th term? In a question like this, I'm going to write this out. T5 being 81, T9 being 6561. What is T11? Well, there's a couple ways to do it. I gave you a question like this for arithmetic sequences, and you had to do elimination or elimination. Because geometric sequence by nature is multiplication or an exponential, the only way to find the difference, or rather the change in the value from fifth term to ninth term, is to find the ratio between the fifth term and ninth term. This is what I mean. I don't think I'm doing a good job explaining with words, so here it is. I do know that the fifth term, being 81, is going to be the first number, r to the power of 4, right? Because remember, 4 is going to be n minus 1, which happens to be 5 minus 1, which is 4. Okay. I also know the ninth term is going to be a to the power of a times r to the power of 8, which is, of course, 9 minus 1. Look at that. These two are going to be compared. 6,561 divided by 81 is the same as the first number times r to the power of 8 divided by a r to the power of 4. If I were to use exponent laws, quick division, this is 81 is equal to a divided by a is a 1, and r to the power of 8 divided by r to the power of 4 is basically 8 minus 4, r to the power of 4. I'm going to do the fourth root on both sides. Let's use a different nut color. Fourth root. That means r is going to be 3. Technically, I guess it could be a -3 as well. All right, so what's the 11th term? I'm jumping the gun. Since I found r, I need to find a. 81 is equal to a negative or positive or -3 to the power of 4, which is the same as a times 81. A is equal to 1. And you will see that if I did the +3 as a -3, you'll get the same answer. All right, so taking all of this information together, T11 is the same as AR to the power of 10, which is 1, positive or -3 to the power of 10, which is something huge. 59,049. Again, notice that this could be a -10, a -3, but because the exponent is even, the entire value is going to be positive anyway. So it doesn't really matter. T11, without a doubt, will be 59,049. Okay. Hope this helps, and keep working. Thank you for the question. Keep asking, and see you next week.